Question 27, Part A. A celebrity mathematician, Carl, arrives in Sydney for one of his frequent visits. Carl is known to stay at one of 3 Sydney hotels. Hotel X is his favourite, and he stays there on 50% of his visits to Sydney. When he does not stay at Hotel X, he is equally likely to stay at Hotels Y or Z. Part 1. What is the probability that he will stay at Hotel Z? It is given in the question that the probability that Carl chooses Hotel X is 50%. However, there is an equally likely chance that Carl could choose either Hotel Y or Hotel Z instead. Let the probability that Carl chooses Hotel Y or Hotel Z be X%. Now the sum of the 3 probabilities, that is 50% plus X% must equal 100%. So I'm going to treat this as an equation and solve for X%. Combining the 2 like terms here, so X% plus X%, we get 2X%. So 50% plus 2X% is equal to 100%. Subtracting 50% from both sides of the equation, we get 2X% is equal to 50%. And dividing both sides of the equation by 2, we get X% is equal to 25%. Therefore, the probability that Carl chooses Hotel Z is 25%. Part 2. On his first morning in Sydney, Carl always flips a coin to decide if he will have a cold breakfast or a hot breakfast. If the coin comes up heads, he has a cold breakfast. If the coin comes up tails, he has a hot breakfast. 1. List all the possible combinations of hotel and breakfast choices. You can either use a probability tree diagram to list all the combinations or a two-way table. I'm going to use a two-way table to list the combinations. So the columns represent the hotels and the rows represent the temperature of the breakfast. So hot breakfast, cold breakfast, and Hotel X, Hotel Y, and Hotel Z for the columns. So the combinations are X, cold, Y, cold, Z, cold, and X, hot, Y, hot, and Z, hot. Two, give a brief reason why these combinations are not all equally likely. Carl is more likely to stay in Hotel X rather than Hotel Y or Hotel Z. So the combinations involving Hotel X, so that's X, cold and X, hot, are more likely to occur than the other combinations, given that the choice of breakfast is equally likely at any hotel chosen. Three, calculate the probability that Carl stays at Hotel Z and has a cold breakfast. The choice of hotel and breakfast are independent events. Hence, the probability that Carl chooses Hotel Z and has a cold breakfast is equal to the probability of choosing Hotel Z, which is 25%, multiplied by the chance of Carl choosing a cold breakfast, which is decided by a flip of a coin, and that's 50%. So 25% times 50% is equal to 12.5%.